Welcome to this video on conditional probability. So we're going to look at conditional probability, and conditional probability is when one event is dependent on the other. So for example, what is the probability that event A will happen given that event B has happened? So we're looking for the probability that A will happen, but we've also been given this extra piece of information that we know event B has already happened. Okay, so instead of writing what is the probability that event A will happen given that event B has happened, we can actually shorten that to the probability of A given B. And mathematically we'd write that as the probability of A given B, where given is a straight line. Now please don't confuse that with the backslash, which is if we're saying one set less another set or without. So they are very different, and make sure that that's very clear when you're doing your work. So it's a straight line, A line B. Okay, so this formula that I'm going to give you now is hugely important. So the formula for conditional probability is the probability of A given B is equal to the probability of A and B happening over the probability of B. Now, here we go. So this formula here, now the intersection, so the probability of A intersection B is the probability that both A and B happen. Okay, so depending on the question, you can be given the probability of A and B happening as just as simply probability of A intersection B equals. But in word problems, we may have to try find that piece of information. And remember, it's the probability of A and B happening. So this formula is not in your log tables. You do need to learn it off and do make sure you know it. So let's take a look at just a quick example. So here's a very straightforward example. They ask us to find the probability of A given B and B given A, and they've provided us with three pieces of information, which is the probability of A, probability of B, and the probability of A intersection B. So let us first start off by writing down our formula so we can get used to it. So the probability of A given B is equal to the probability of A intersection B all over the probability of B. Now let's sub that in. This is what we want. We want A given B, so we don't know that. And the probability of A intersection B is a quarter, and we're going to divide that by a third. Okay, so you can put that into your calculator, but remember, if we want to divide by a fraction, we multiply instead by its reciprocal. So flip it, 3 over 1, which equals to 3/4, which equals to 0.75. Now, just before we do this, I suppose maybe to have a little think, do you think that the probability of A given B is the same as the probability of B given A? So let's investigate to see if that's the same thing. Like, does it matter? So B given A. Now, in this case, it's the probability of B and A happening over the probability of A. Now, just to make a quick note here, the probability of A and B happening is the same as the probability of B and A. We're just saying it backwards. So the probability of A and B is the same as the probability of B and A. So it's no different. So we're going to sub in what we know. So it's probability of B given A is equal to, we still have a quarter, but this time we're dividing by a half. As before, remember, when you're dividing by a fraction, you can always multiply by its reciprocal, which means you're going to flip it, which this gives us 2 over 4, which simplifies down to a half, which simplifies down, well, we'll turn it to a decimal, 0.5. So here you can see that the probability of A given B and the probability of B given A are not necessarily the same. Now it can turn out that they are, but that is coincidence. In the majority of cases you'll find that these two are different. So do be careful with that. So now let's look at an example which involves a Venn diagram, and Venn diagrams have come up. They're not hugely straightforward when they come up, so it's important that you're able to work with them and all the different notations, that you understand all those different notations that you see. So they've provided us here with the Venn diagrams, and within the Venn diagrams they've actually given us the cardinal number, which means or rather in this case they've given us the probability of it happening. You'll notice that all of those are less than 1 and they should add up to 1. So if you want to just double check, you can add all those numbers in the diagram and they'll add up to 1, so they are the probabilities. So we can see straight away that we're using conditional probability because they've asked us to find A given B, B given A, and A given B union C. So first of all, let's write up our formula. So the probability of A given B is equal to the probability of A and B happening, so that's the intersection point, over the probability of B. So now we'll be able to get all that information as we want it. So for our first example, or for the first part of that question, we want to find the probability of A given B. And to do that, we want to find A intersection B. So that is equal to 0.09 plus 0.07. So we're looking at this piece here. So the whole place where A and B intersects. Okay, be careful, it's not just the 0.9 because they intersect on both of those parts. So we'll have to add that together all over. Now the probability of B, make sure that you add all the pieces of B together because B represents the full circle. So B in this case is this full red circle. So to find the probability of B, we have to add all those pieces together. So 0.1 plus 0.04 plus 0.07 plus 0.09. Now, so if we can clean that up, we get, so 0.16 over 0.3 and when we clean that up, we get 8 over 15, or if you want to change it to a decimal, although it is a recurring decimal, it's 0.533 reoccurring. Okay, so that's the first part. So let's take a look at part 2 then. So it asks us to do the opposite, and in the last example we already discovered that the probability of A given B and the probability of B given A are different. However, we did say that the probability of A and B happening is the same as the probability of B and A happening. We're still looking at the intersection of A and B, so this is 0.16 as it was in the last question. Now, underneath the line this time, we want the probability of A. So if you go to your Venn diagram, to find the probability of A, you have to find everything that's in that circle. So in that circle, we have 0.4, 0.09, 0.07, and 0.1. And when you add all those together, you should get 0.66. Okay. So then you want to work those out and we get 8 over 33, and you can put that in a decimal, but again it's recurring, so 0.24, and both the 2 and the 4 recur. Now I've just cleared that just so we can have a bit more space to work. So let's work with part 3. So the probability of A given B union C. So remember, just when you started out, you would have learned BIMDAS, so back in first year. We're going to have to follow that. So we want to do what's in the brackets first. So B union C are together. So what that actually means for us is it's the probability of A intersection B union C all over the probability of B union C. So let's see where B union C is in this case. So B union C is going to be this piece here, okay, that I've highlighted in yellow, okay? Where A intersects with B union C is just in one little point, and that point is here, okay? So that piece there is the probability of A intersection B union C. So let's sub this in. So 0.07 all over 0.07 plus 0.04, which is 0.07 all over 0.11. So let's simplify that. And we get 7 over 11, or we can write that in decimal form, which again is recurring 0.63, where the 6 and the 3 recur. So you do need to know your notation of intersection, union, and one thing that does seem to come up quite a bit is complement, which we will look at in a few examples time. So now let's look at a conditional probability word problem. In a certain county, 70% of the population live in a townland and 30% live in a rural area. 50% of townlanders listen to the local radio station, whereas only 20% of rural dwellers listen to the local radio station. A person from the county is picked at random. Find the probability that this person is a townlander, given that the person listens to local radio. Now, so what they're asking us to do is the probability that a person is a townlander given they listen to the radio. Now, to do that, we need to know the probability of T intersection OR, so that they are a townlander and they listen to the radio. And this goes over the probability that they listen to local radio. So in order to do that, we need to know the probability that somebody listens to the radio. Now, the problem here is we know that 50% of the townlanders listen to the radio and 20% of rural dwellers listen to the radio. But that's 50% of the 70% and 20% of the 30%. So we have a little bit of working out that we need to do. So in order to help us do that, I would suggest a table, so something like this. So we have townlanders, so we'll call that T, and we'll call rural people T with a line over it, so not townlanders. The only reason I'm going to use T with a line rather than OR is so we don't get confused with radio. So listen to the radio then we'll say is OR, and do not listen to the radio is OR with a line over it. Now, I know that the total percentage of town dwellers is 70%, which is 0.70, and for rural dwellers it's 30%, so we're going to put that into decimal. So when we're talking probabilities, it usually is easier working in decimals. Now, we were told that 50% of townlanders listen to the local radio, so that's half of that 70%. So that means 0.35 listen to local radio and 0.35 do not listen to local radio. We were then told that 20% of rural dwellers listen to local radio. So 20% of 30% gives us 0.06. So if you want to just make a little note, so to get that, we multiplied 0.2 by 0.3. So 20% of 30% in decimal form, which gave us 0.06. That means there's 0.24, so 24% don't listen to the radio. Okay, so let's add all these up. So this will give us 0.41 when we add these two. Here will give us 0.59, and when we add that together we should get 1. So when you add 0.7 and 0.3 we should get 1, and when you add 0.41 and 0.59 we should also get 1. So that's good. So all the probabilities should always add up to 0. Or sorry, should always add up to 1. So now let's go back to our formula which we had up here. and let's fill in. So the probability that somebody is from the town, so is from a townland and listens to the radio, so that would be here. That is townland and listens to the radio, so 0.35. And that's all over the probability that somebody listens to the radio. So that is, doesn't matter where they live, they listen to the radio, so that's 0.41. Okay. So when you put that into your calculator, all that it does for fraction is simplify to 35 over 41. Okay, and then if you want to turn that to a decimal, so 35 divided by 41, so what we get is 0.853658. Okay, now what I would say is, since all of these have been given to us in percentages, that we should probably give this back in a percent. So let's give it a percent back with 2 decimal places. Now they didn't state how much they would like, so how many decimal places, but if you turn it to a percent and 2 decimal places, you're giving them quite a bit of quite a bit of accuracy there, because effectively that is 4 decimal places for if you had left your answer in decimal form. So the answer here is 85.37. So I would say just be really careful with these types of questions. Sometimes what we get in the question, the actual figures themselves, do not represent what we think they represent. So something like a table or even a Venn diagram can be useful. I think in this case a table was a bit more straightforward. Now let's take a look at a conditional probability exam question which uses Venn diagrams. So they tell us that two events A and B are such that the probability of A is equal to 0.2 and the probability of A intersection B is 0.15 and the probability of A complement intersection B is 0.6. So let's deal with these one at a time. So they have asked us to complete the Venn diagrams. The first thing we're going to look at is the probability of A. So the probability of A is going to be this full circle here. So that full circle already contains 0.15. So we're going to have to take that away to find out what will be left to just place in the main part of A. So this is A without B. So the part that is just the probability of A but not B. Okay, so the next part then they told us was the probability of A intersection B was 0.15 and they'd already put that in. If they hadn't given that to us, you always need to fill in from the inside out in a Venn diagram. So we always start at the centermost point. If there's 3 Venn diagrams, obviously that's a little bit different, but in this case it would just be where A and B intersect. Now the last piece of information that they gave us was the probability of A complement. Now this is an important one to know, since the complement is not actually given in the log tables where the set notations are given. So you need to know this. So this basically means everything. So everything except A. Okay, so it's the opposite to A. So what that means for us is basically everything in this Venn diagram that is not A. So we're roughly looking at all this bit here. Okay, so we have all of these pieces. Now we want to know where that intersects with B. So if we just draw a ring here around B, so this is where B is. We're talking about the piece where they intersect. So they intersect at this part here. Okay, so this piece here is what we have as P, is the probability of A complement intersection B. So in here we're going to put 0.6. So that's the first part done. Well, we're not fully complete yet because we have to then see, is there anything that does not sit in A and does not sit in B. So we filled in the Venn diagrams based on what information we were given, but we also know that the probability of a full universal set, so we see the Venn diagrams in this square box, the full universal set S, we know the probability of that should be 1. So let's make sure that all of these add up to 1. And that is what they're actually asking us to do in the second part. Find the probability that neither A nor B happens. So is there anything outside of A and B? So let's work that out. So the first thing we're going to do is we're going to find out how much or what probability A or B has. So this is the probability of A or B, which is union. So when we work that out, we get 0.8. To find out the probability of A or B not happening, that's going to be just 1 minus the probability of A union B. So it's A union B complement. Okay, so it's going to be 1 minus 0.8 equals 0.2. So 0.2 appears out here in our Venn diagram. So part C of this question then is asking us about conditional probability. So they've asked us to find the probability of A given B. So let's use our formula. The probability of A given B is equal to the probability of A and B happening, which is intersection, over the probability of B. Okay, so let's sub in. Now we're using the Venn diagram from the previous part. So if you remember the probability of A intersection B, so the intersection was 0.15. Now the probability of B, so the intersection was 0.15 plus we had 0.6 as well. So that gives me 0.15 over 0.75, which simplifies down to a fifth, which gives me 0.2. So just be really careful with the Venn diagram questions that when you do the probability of A or the probability of B, that you are taking the whole of A and the whole of B.